I'm Ryan. I am the CEO and co-founder of Earthmover, and I'm really excited to share what we've been building, our data marketplace. And so I'm going to show a little bit of show some slides to kind of explain how we got to this idea, and then I'm going to give an interactive demo and walk you through how the marketplace actually works. Okay, cool. So let's dive in. First, just a little bit about Earthmover. Earthmover is a startup, a public benefit corporation with the mission to empower people to use scientific data to solve humanity's greatest challenges. It was founded by myself and Joe Hammond. And we really got our start in the open source world. We're both maintainers of the Xarray library, and that's how we met. And that's how a lot of us in the company came together. And what we're really trying to do with Earthmover is take the amazing, foundations of the cloud native open source scientific data ecosystem from Xarray, Czar, and Pangeo, and turn this into a real enterprise grade cloud native data platform that can really accelerate work at organizations around the world. Um, we've been running our platform with users for over a year. And we've sort of observed some recurring patterns with how folks are interacting with data. And these are what motivated the Earthmover Data Marketplace. So this really starts from the sort of traditional paradigm for how data are disseminated in the Earth observation and Earth system data space. Traditionally, there's been a pretty strong divide between a data provider, you can think of this as a big government agency, and a data user, an individual scientific researcher. That's how a lot of our data systems were, designed around this paradigm of interaction. It's this pretty one-way exchange, and there's a big mismatch in size between these two organizations. All of that is being disrupted right now, that traditional paradigm. Um, there's three big trends that are active right now that are causing us to rethink how data are shared and disseminated and organized. The first of these is AI. So obviously you have to be living under a rock not to be aware of how AI is reshaping how we interact with data and with the world. Um, in terms of Earth system data, AI has a voracious appetite for training data. And so what we see is that people who are doing AI and developing AI models need access to entire data archives, not just a few pieces, small pieces of data. AI research is also very centered around this idea of shared benchmark data sets. So folks using the same data set to compare and validate their models. And then finally, there's something that I'm really excited about, which is that AI is enabling smaller teams to become data providers. You no longer need to be a big government organization to produce a valuable and impactful data product. And so we see this across our customers, teams who are producing, small and agile teams are producing very important and relevant data sets that have a wide audience. So this sort of gap between research and operations is narrowing and the spectrum of data providers is widening. The other trend is cloud computing. Cloud computing is really transformative because it enables any organization to access large-scale storage and compute without a huge upfront capital cost. So, a team can spin up a big GPU cluster and spin it down the next day, and they don't need to have a big data center in their basement. Cloud is also changing how we interact with data. Um, with cloud, we can bypass downloading data onto local disk and we can access data directly from cloud object storage if our technology supports that. And then finally, we see a strong trend and we're excited about the strong trend towards open science. Open science is really the practice of bringing the research process and all of its artifacts more out into the open and making it more collaborative. And so what we see in open science is that distributed teams need to share data sets throughout the research process. Also that funders are mandating the sharing of data as part of the publication process. And this dovetails with the AI trend, which is very much oriented around open source. And so the traditional data distribution paradigm is struggling under this new environment. To get real specific, if you are trying to do scientific AI and the first step in your workload is have to download thousands and thousands of GRIB and netcdf files, that's going to be a big pain, right? So those files in a cloud context don't give good performance. They're slow to load and analyze. Therefore, what we see is teams are transforming those data sets into other formats to make them more accessible to compute, more accessible to AI. But that whole process of sort of re-ingesting, reprocessing all the data also incurs a cost for everyone who wants to work this way. And it slows down teams, it slows down iteration, it ultimately slows down science and innovation. Now, we're lucky that we have a great new standard emerging for cloud-based AI and analytics-ready data. So this is what we call ARCO data, analysis-ready, cloud-optimized data. So in the ARCO data paradigm, data are organized into hypercubes, which allow arbitrary slicing across any of the dataset dimensions, rather than organized as individual files or granules that must be downloaded and looped over. And then cloud optimized means that the data are designed and optimized to be read from cloud object storage in an efficient, scalable way so that we don't need to have a download or data ingestion step to use the data. So all the teams we talk to in this space really want to be using ARCO data, and the challenge is how to get it. Now, as part of this, I want to plug a key technology we've been working on at Earthmover, something called IceChunk. So IceChunk is really the new standard for the best practice for how to do ARCO data in 2026. So IceChunk you can think of as a high-performance tensor storage engine. It really works together with ZAR. So if you're already using ZAR, it's very easy to adopt IceChunk, doesn't require many changes in code, and it makes those ZAR datasets go way faster. So this figure over here, I know it's very busy and full of a lot of different lines and plots, and it's probably hard to parse if you just look at it the first time. I encourage you to check out our blog post. But what it shows is that IceChunk is by far the fastest way to read and write tensor or multidimensional array data in the cloud. Much faster than ZAR without IceChunk, and also faster than most other array storage libraries that exist out there. It's really capable of fully saturating the network and providing maximum performance in high performance AI and analytics workloads. And so this is key to what we're building here, the ability to load data very fast and very efficiently. In addition to just the performance, IceChunk also brings a lot of features that are really needed to put this ARCO data concept into production. Specifically, ACID transactions, so the ability to commit a bulk of changes to one of these data cubes and then potentially roll back those changes. It comes with data versioning. It offers a virtualization capability, so to layer over on top of netcdf or other file formats. It's 100% open source and serverless. So anyone can use IceChunk today, and we're really excited to be seeing a growing number of teams building on IceChunk. I just got back from AMS last week, and we talked to teams at NOAA, teams at Spire, teams at a bunch of different AI startups. Everyone who is really doing serious AI with this type of data in the cloud is investigating or adopting IceChunk. So I encourage you to check it out, irrespective of all this marketplace stuff I'm going to talk to you about. So what we're doing at Earthmover is we're trying to take this ARCO concept and turn it into a full stack data platform. And so our company builds and sells a data platform called the Earthmover platform that really allows you to operationalize this idea of ARCO data. We provide a data catalog, access controls, and integrations like webhooks that allow you to plug that data into your workflows. We have an API layer called Flux, which provides a lot of different ways to query and interact with that data, in addition to querying it directly from Python. And we do this sitting on top of your cloud object storage using this open source format IceChunk. And so what we've recently just added to this sort of platform diagram is the green square in the middle, the marketplace. So I'm going to tell you a little bit more about how the marketplace works and what it does. So first, you can think of this as a model for how the Earthmover platform worked before the marketplace. Had many different customers storing and managing data within their organizations, but essentially siloed, where each team had their own data sets in their own storage, and those didn't cross-pollinate or talk to each other in any way. We observed that folks were spending a lot of time on data ingestion, and we also observed that many of the teams that we were working with actually were ingesting the same data sets over and over again and running the same sort of transformations. Things like ERA 5, ECMWF forecasts, NOAA forecasts, etc. And so fundamentally, the way the marketplace works is it enables this cross-organizational exchange of data. It allows one organization to securely share data with another organization using a mechanism called credential vending that allows them to access data in another organization's storage securely and safely without risk of data leakage. And then what's coming soon is this idea of cross-bucket data replication. So rather than actually accessing data from another organization's storage, it can actually be replicated directly into your organization's storage. So what this unlocks is true cloud-native data sharing. So this provides some pretty unique benefits for both data users and data providers. On the data user side, fundamentally what this enables is instant access to high quality ARCO data and the ability to bypass this really costly and slow data ingestion and transformation process that we see so many teams struggling with. The data is high performance, so designed directly to be used for AI and ML workloads. There are many free and open access data sets in here, so that is a huge benefit for folks. And then we also have commercial data sets with SLAs that are available under a paid license. So this is really ideal for teams in energy, commodities, utilities, insurance, finance, agriculture, and also researchers who need access to high quality data sets. Now, on the data provider side, we're making it much easier to distribute that ARCO data without having to build and maintain a lot of complex architecture. We enable data providers to share free and open data and also private and proprietary data through a single secure platform and an open source format, IceChunk. We've designed this in the way to allow the data providers to maintain control and sovereignty over where the data is stored, how they're licensed, and how they're priced. And then we have metrics that enable the data providers to understand usage patterns and how people are getting value from their data. So we're thrilled to be launching the marketplace with a cohort of amazing data partners. These are folks providing data within the Earthmover Data Marketplace. So these include Brightband, providing some really great data products from ECMWF data, as well as some machine learning weather prediction archives. I'm actually not going to name every provider's data set right now. I'm just going to jump over into the demo. So I'll walk through some of these data sets. But we have Brightband, Beyond Weather, Climate Uncertainty Lab, Dynamical, the Subseasonal Consortium, Zeus, and Planet. And we're already preparing another crop of data partners for our second batch of releases. So I'm going to jump over into the demo, but I just want to conclude in the slides, sort of explain our vision at Earthmover is to enable frictionless global data exchange in this AI era. We're working really hard to modernize how we as a field interact with data, and the marketplace is a big part of that. It's a big step on our journey towards this goal. So I'm now going to jump over to the marketplace itself and walk you through a little bit of a demo. So let me go to the marketplace. You can find this at app.earthmover.io/marketplace, and it's free and open to everyone to access the marketplace. So what we see here is a range of different data sets from different providers. We've got over 20 different data sets in the marketplace today. I'll go through and click on one of these. The first one here is from Brightband, and it's a machine learning weather prediction forecast archive. So I'll click on this and I'll just walk through what you can see in the interface. So the first thing we see here is just the dataset README. This README is just a human readable description of what the dataset is, how it's organized, references, and other relevant information about the dataset. In this case, the dataset we're looking at is a archive or a reforecast of several machine learning weather prediction models that can be used for folks to evaluate the model skill and decide which of those models is potentially a good fit for them. We can go on this tab and click and actually see the data set. So we can see that it's organized hierarchically. So we'll go look at GraphCast, and then we'll go click through here, and we can see a really nice visual representation of what the data set contents are. In this case, it's a 5-dimensional data set, or rather 4-dimensional data set. We've got lat, lon, init time, and lead time, and we can see we've got a half dozen different variables over quite a large domain of space and time that we have access to here. This is fundamentally ZAR data, so we can see the shape of the data, the chunks. We can look at the attributes of each of these different data sets, and really dig into the details of how the data are stored and encoded if we like. And then finally, we can see the license. So all of the free and open data sets are going to be available under some flavor of a Creative Commons license. And then the commercial data sets will be available under different terms and conditions. So how do I go about using one of these data sets? Well, the basic idea is that what we're going to do is when we want to access one of these data sets is we're going to subscribe to a data set. And so I'm now going to go create a subscription within Earthmover that's going to point at this source data set, but it's going to live in my organization. So in this case, I've got an organization set up called Vandelay Industries. This is a fake company name, and I'm going to just call this MLWP WP archive, and I'm going to create that subscription. And now, ta-da, I've got this as an ArrayLake repo. So this is one of the sort of core entities within our platform. And at this point, I can now interact with the data. I can browse through it as I was doing before. I can see the dataset contents and try and understand what's in there. I can also access the data directly. And this is the point at which I can get to work integrating it into my workflow. In a minute, I'll jump into Python, but I just want to show you some of the other options. We support web map tiles on top of these data sets. So if you actually want to visualize and interact with the data, let's just grab the 2-meter temperature and set up a basic visualization. And this is going to allow us to just browse through and explore this data on a Slippy map. Also easily build our own application that would use this backend in order to serve data into our own custom dashboard using OGC standard protocols. What most people are going to be probably doing, though, is just going straight to Python and accessing that data from Python. And so over here, we've got some code that we can run that will connect directly to this repo and the data set that we're interested in, and just access it directly from Python. So I'll just pop over to another tab. I'm going to run some of these cells here. I'm going to delete this one because that's not relevant. And I'll just paste that code that I just got over from the app in here, and I'll have my data set right here in Xarray and Python immediately. And so this is the same data we were looking at in the web. Now we're seeing it as an Xarray data set. I'm just going to quickly make one change here. I actually don't want to use Dask here, so I'll just say chunks equals none. And now we've got this data set. And if I want to query it and make a plot of a particular forecast time, forecast at a particular point in space and time, it's really easy for me to do. I've got all my familiar Python tools at my disposal, and I can now integrate this into whatever comes next. And so this is really what we mean by cloud native data marketplace. There's no ingestion step. I didn't have to download anything. I don't have to do anything to prep or manipulate this data before I can use it. The moment you subscribe, the data are ready to use. So I'll just go show some of these other data sets that are available in the marketplace. So I'll just now quickly run through some of the data sets that we have here. So we've got from Brightband, we've got obviously the one I just showed. We've got an IFS forecast, so ECMWF's deterministic forecast. We've got both an open version of that and a low latency version of that that is suitable for operational use in energy, commodities, agriculture, anything that really needs that high performance, low latency forecast data. We've also got some ensemble initial conditions that are suitable for initializing those MLWP models. Then we've got dynamicals data. So dynamical is producing some forecasts of the is rather producing some NOAA forecast data cubes. So these are from HER and GEFS. We've got data from Planet. Planet is a startup making seasonal to sub-seasonal forecasts. We've got an Era 5 data set. This one is actually from us, Earthmover. We have Zeus that's producing solar irradiance forecasts directly from observations. And then we've got the Climate Uncertainty Lab of Columbia University producing a new bias-corrected downscaled climate prediction data set. And then finally, we've got the Subseasonal Consortium that has a really exciting collection of subseasonal forecasts that are all gathered together into one archive here that you can interact with and subscribe to through the marketplace. So I think I will stop there. I'm eager to get into the Q&A and answer any questions that folks have or just get your comments on what we've presented today. So I think I will stop my screen share and yeah, open it up to questions. Margaret, how should folks submit their questions?
You should submit them using the Q&A module that's found in the Zoom control bar. I don't see any open questions right now, but we do have a poll up that says, what data sets would you like us to have or add? So whether you've had a chance to browse the marketplace or not, we'd really like to hear from you all because we can look for somebody who provides them just to facilitate, your own development cycles without having to write your own pipelines.
Yeah, that's really what we're trying to achieve here. If we're successful with the marketplace, what that means is that folks who are working with this type of data can just skip a huge, heavy, time-consuming, and expensive step of this process and just get right to work on the more exciting, interesting data science, machine learning, analytics, research, whatever it may be. So that really is our goal, is to accelerate your roadmap and allow you to just iterate faster and ship faster.
Ryan,
So
there's a question here that's going to make your day from Gregory, which is, can the data be queried via SQL?
That's a great question. This is something that we have on our roadmap, and it's something we're actively developing. So, I previously showed you how we could query map tiles, and we have several other API protocols. And SQL is the thing that we've had a lot of interest in. It's a little tricky because the data are not fundamentally relational; they're multidimensional array data, and so the trick involves trying to map the relational model to the array model, and it's something we'd love your feedback on, Gregory. So if you have specific use cases for that, maybe we'll follow up with you and try and get some input.
Yeah, thanks for the question. There's another good one here from Saeed. I hope I said your name right. Hi, Ryan. Thanks for the great talk. The Python access is limited to beta subscribers, right? Even for the free data sets?
So I'm not sure I quite understand, but let me just clarify how this works and who can access it. Anyone in the world can sign up for the Earthmover platform and access the free and open data sets. So there's no beta subscribers that doesn't exist in our platform. And right now, anyone can come create an account and access the free and open data. For paid data sets, you must be an Earthmover paying customer because we need to bill you for those subscriptions in addition to other platform fees. So that's basically how it works today. This is for free and open data. The access is free to the platform, whereas for paid data, that does require a commercial account with Earthmover.
Okay, we've got one here from Nick. Very cool. Love this work and its potential. Technical questions that may not be of interest to everyone. Oh, they will, Nick, whatever they are. What is the connection between data sets and open source abstractions in Python? Is it one data set to one version via ice chunk czar data set? He's got some more, but we'll pause there.
Yeah. Okay, great. I see these questions. So these are great
Great,
questions.
great.
So yes. Um, so yes, ice chunk is the unit of the subscription. So each uh, listing you see here corresponds to a and I'll just share screen again to make this a little bit more concrete. Corresponds to a specific ice chunk repository, and here we can even see the details of where in the cloud that lives, the cloud region. This one happens to be in Cloudflare. And so, yes, Ice Chunk is the medium of exchange for all of this. Now, an ice chunk repo does not necessarily have to be one data set in Xarray terms. So you can contain a hierarchy within these ice chunk repos. So for example, if I go over and look at the data set for the MLWP archive, we see it's got some hierarchy. There's some groups, and within those, there are subgroups, and those are the actual data sets, to use the Xarray terminology. As for your next question, oh, and so versioned. Yeah, so the subscriptions are very much designed around the idea that the data are going to be updated frequently. And so the Ice Chunk really enables that because it has a very clear sort of sequence of updates that are described through the Ice Chunk transaction log. Okay, next question is how is chunking handled? So we don't have any specific constraints on chunking. That is really something that is up to the data provider. One thing that we do see in some of these data sets, so for example, in our Era 5 data, we actually provide multiple versions of the same data set with different chunking schemes. So here we have one that's optimized for spatial queries. You can see that has spatially contiguous chunks. This is like what you would see from Google's Arco Era 5 data or Weatherbench. But then we have another version of this that's optimized for temporal queries. And so these are sometimes what we call churro chunks. And these allow you to query across all of Era 5, and drill down as time series. And so, as we evolve the marketplace, I think we'll see sort of more of this happening and also more tooling that emerge to make it easier to sort of deal with that type of multiply chunk data. This is a pattern that we think is going to be really powerful. Finally, another thing that we're developing, as part of like the marketplace roadmap is the ability to actually, when you subscribe, to choose to rechunk the data into a different chunking scheme if that is more aligned with your query patterns. And so that requires a lot more processing, but that's something that we can achieve. And then finally, do we have instructions for data providers interested in participating on the platform? Yes, so if you go to our docs, first of all, you'll read a bunch about how the marketplace works. So if you go to this, we have docs aimed at both the data provider and the data user. And so basically, if you want to be a data provider with us, just send us an email. And I think we also have a form for this, Margaret, right? You don't just have to email us. So we're very excited to work with data providers. And if you're interested, we'd be happy to follow up with you. I think we're out of time, and I think we've gone through the most of the questions. So I want to thank everybody for joining us. Margaret, any final business we need to share?
Thank you all so much for the poll answers, and we will certainly follow up with a recording and those poll responses. Thank you for being here.